After loading CamTrap Pro, having installed it, you should see the screen as follows, and which indicates that you're running with the demo license. So click OK, and now the CamTrap Pro screen appears. Now we want to load up a license, so the first thing we need to do is to find the license key, which will be selected from the user license keys, and depending on which week of data you're processing, you can use one of these license keys. For our example, we're going to use week 1, so we'll select this key, copy it, go back to CamTrap Pro, open the license screen and paste it in. And we don't need to close and reopen in this particular case. So I'll now close this window and we're ready to go. So now we need to load some data. So in order to do that, we select File, Open Folder, and we go to the data which we wish to analyze, which in your case will be on a removable drive. This is also on a removable drive that I'm about to load, but we're going to load up first of all a camera data from week 1, camera 32. So here it is. Click OK. And now it appears. Okay, so that's the first image, which is probably when someone was putting in the camera, which is why it's on a slant. But we want to look at the count versus time profile of this data. So we click count versus time, and we want to show all of these things, even though none of them have been applied yet, highlights and tags and tag names. So if we click OK, we now see the count versus time profile. So in order to speed up the processing, we can use some results from AI processing of these images to detect the presence of humans, vehicles or animals using a detector called megadetector. And the results from this are stored in a JSON file, which we will now load up. And this file is in the root directory for the particular week, and it's called image recognition file .json. So that's now loading. First of all, deserializing, which means putting it into a form that the computer can understand, and then it will run through all of the files. The file which is in your removable drive applies to all of the weeks of data, so where it just skips over all the weeks that you haven't got, and where it's actually found them, it will run much more slowly, as it's doing now, and it shows you how many detections it's made as it's processing. So I've got about another minute to go. And this window comes up. Now you can see that there are most of the time versus depth profile is now blue, indicating that megadetector has detected an animal in this in that particular image. Now the results of megadetector are actually stored in the file name. It changes the file name, so we need to reload the data to account for the fact that the names of all the files have changed. And there we can see it. Okay, well now if we start scrolling through the data, if we just move on a bit, and also show that detections are enabled, we can see that we've got a bounding box drawn around an animal. You can see it moving in this particular case with pretty high confidence, and also on the time versus depth plot, the highlight has the file which is being viewed is changing, and also the slope. Right, so now we've got the highlights. You can see that the profile contains a number of steps. So a useful thing to do is to have a look at all of these steps where megadetector has detected an animal. And if we zoom in, let's just zoom a little bit more. You can see the individual data points here. If we click on the blue triangle, you can see that immediately that's a false detection. It's just detected the bait, so we don't really want to do anything with that. So let's zoom out again and move on to the next detection. So we'll have a look at these ones in here. Not sure what that is. Again, it's the bait. And once again, it's the bait. So we don't need to do anything with that. Here's another detection. Again, it's detected the bait. Now here's a sequence where there's been a detection in a number of successive images. And this is at night. And you can see that it looks as though a kangaroo is having a look at it. Unfortunately, we don't know which kangaroo it is. But if we'd like to tag all of these images with an unknown animal. So here's the tag, the window where all of the presets are defined. Now you can see there's nothing which is predefined already. In order to add these, we'll click on the Add button and we'll read the data from a file. Now in this case, the file is on the computer desktop, but in your case it will be on the removable drive, and they're just called presets for Ainsley Majura. So you can see there's quite a lot of them. You add them, and now here they are. And so now we're ready to add what unfortunately is an unknown animal, because we don't know what sort of kangaroo it is. You can see that there's an eastern grey, a wallaroo, and a redneck wallaby, and we don't really know which of those it is, so we have to say that it's unknown. So we select that, the tag goes into that box, and it will now be applied between sequence numbers as shown below. We click apply, and off it goes. And after the tags have been applied, the tag summary data is filled as shown in this progress bar, and the tags are now shown on the count versus time plot. If we move back out again, the labels should obligingly move, won't all be on top of each other. So we've done one of the interesting appearances in this data set. Let's zoom out and move on to another one. Okay, so let's have a look at this here. So let's have a look at this file. This looks like a shingleback. So by using the right and left arrow keys, we can move through the data and see that there's a shingleback. It slips out of the frame for a moment, but then re-enters from somewhere else. If we go up to this time here, click on that, and there's the shingleback again. Now, in order to monitor the abundance of animals, we use something called a detection event, and a detection event occurs when an animal appears in one image and its successors, and the gap between any of the images is less than 10 minutes. So if we now change the grid interval for 10 minutes, you can see that that is actually will appear as a separate detection interval. If we now go on to this other plot here, which seems to last for about 20 minutes, we can see that looks as though we've got two shinglebacks there. No, that's a bird. So we change. That is actually a bird. So what we want to do is to flag all of these as shinglebacks. So if we go to tag multiple again and select shingleback skink from the options and apply, This takes a little while because you're having to actually change metadata on all of the files and update the information in the which is stored inside the program. So there it is. Zoom back out again and the display gets a bit more manageable, and you can see that there are two separate occurrences here. Now if we go to this next block of data here, looks as though nothing much is happening there. Let's step through. So it looks as though we've just got waving flowers and moving shadows, which aren't really indicating, but here's a bird. So if we go here and have a look at all of these images within the within this step, you can see that this looks like a bird which is hanging around investigating the bait, and it's still there. What sort of a bird is it? We'll have a good look. That looks like a red eye, so I think it's a white-winged chough because they have white wings and red eyes. So we now say that we'd like to tag all of those files which are shown on the screen at the moment, and we'll say it's a bird and it's a white-winged chough, so we'll apply that tag. Okay, and there it is. So if we go back out and view the entire plot again, we'll go back to the default time interval. You can see that we've now put tags on a fair number of the files of interest. So basically the process is just doing that for to examine every group of files where Megadetector has actually detected that an animal is present. Sometimes it's right, but it's not always right. So now we'll move on to a very different data set. This one is quite good because most of the triggerings of the camera were from animal movement, but this is not always the case. If we move to another data set, which is AM02. This is much larger, it stretches over 2 files, and it has 11,000 images altogether. So it starts off with someone's hand. So we'll go to the count versus time. Which takes quite a bit longer to load now because we've got a much larger number of files. And you can see that this has a very different profile. It's basically smooth, there aren't any steps, and the time really just goes over just over 2 days. So we've had an awful lot of images collected over quite a short space of time. There are no obvious steps in the profile. Anyway, we'll run Megadetector over it and see what comes up. So we'll go to Highlight Machine Learning, and once again we'll load the JSON file and wait for it to process. Okay, and now it's finished. So we'll reload the data. And now we can see that there are many fewer over-threshold detections in this case. So we'll have a look at them and see which ones of them are animals and which ones of them are real. But before we do it, we'll change the view detection option to include showing also all the detections which are below the threshold, as well as those which are above one. We can see now that we've already found one in that apparently blank image. But we'll just zoom in first of all and have a look at this fellow here. So if we click on him, oops, we've missed there, but let's go back. Forward. Oh, looks as though that's a butterfly. So we've got an over-threshold detection of the entire butterfly and with a confidence of 0.43, and an under-threshold detection of part of the wing with a confidence of 0.005. Now we're not really interested in butterflies, so we'll pass that by. Let's zoom out again and have a look at some of the other detections. You'll agree that this is much quicker than examining all 10,000 photos. So let's zoom in again, click on there. Oh, it's our friend the shingleback. So we'll definitely tag him. Let's just go forward. We'll just go onto the main screen. And there he is, just disappearing at the bottom left. Go a bit further forward, gone all together. Go back. Here he is detected. Oh, and here he is with a below threshold detection. Now this is a fairly typical case where an animal does spend some time in front of the camera, and it does actually trigger it, but Mega Detector doesn't do a great job of detecting it. And certainly just looking at that image, it's very hard to tell that it's an animal. But now it's much easier. So we'll just add a single tag here. We'll go to the presets menu, which shows much as before. Shingleback skink, and we'll copy it to the tags and apply it after copying. And now we'll update the tag occurrence data. And so there it is now, now tagged. Let's zoom out again. And move up here to have a look at this particular image. Now that's below threshold. When the detections are below threshold, the icon in the top corner here is orange, and when it's an over threshold detection, it turns red. And again, this is a butterfly, which we're not interested in. So we'll close that. Zoom out again and have a look up here. Let's just go forward a bit till we see the icon light up red. Just going a bit further, we're not quite on the money there. That's better. And now we've got a specious, a false detection, in this case from a flower. It's got a value of 0.513. You can see it here, and there's also a below threshold detection also on a flower. But again, nothing that we actually want to tag, so we'll finish with that one. And have a look at all of these. Now there are quite a lot of these, and they're kind of isolated, so I suspect that these are probably false detections, but let's have a look. Let's click on it. Yes, that's just a bit of grass. Another bit of grass. Looks like more grass. These are all below threshold detections, so I don't think that we've got an animal here. Okay, move on to this fellow. Now if we just zoom in a bit further, when you're actually over a single image, the icon goes to a cross. So now right click, and that's a bit of grass, don't need that one. More grass. More grass. And if you're really keen, you can check all of the others, but it looks as though all of these are simply moving grass, and they indicate that perhaps we could use a higher confidence range and not have those as detections at all. But it does look as though in this fairly large data set of 11,000 images, we've just got one photo of a shingleback which is over threshold, and a couple of others which are under. So didn't really detect very much. Anyway, that shows you how the processing works. So let's close off this video for the time being.